The year 1500 represents a system boot sequence, the moment the initialization phase finally stabilized. This leaves everything we know as classical antiquity as a pre-rendered lore file, generated to provide the simulation with a coherent backstory. Baalbek functions as a massive Sistina failure, a profound software error embedded deep within this simulated dataset. The foundation of the Jupiter Temple and the nearby Stone of the Pregnant Woman present an absolute wall in the physics engine. These stone blocks weigh in at exactly 1,000 tons. Because the standard human history dataset lacks the logistical parameters to process physical variables of this magnitude, the mainstream timeline remains structurally compromised. Skeptics point to Roman avatars as the primary builders, suggesting standard manual labor and ancient engineering accounted for the site's construction. Historical figures like Augustus occupy these environments as programmed assets, deployed to render a plausible narrative for the users within the simulation. This photograph of a Roman Laufradkran scale model illustrates the primitive nature of the tools cited by mainstream history. Legend suggests a combination of these wooden structures and pulley systems could manipulate 1,000-ton masses. However, treating a 1,000-ton block as a constant mass while using these mechanical tools causes an immediate physics engine overload. Understanding their movement requires a forensic analysis of the source code. This digital framework comparison table shows the system override as the only validated model for the site. Mainstream archaeology and alternative history frameworks both crash because they operate on the assumption that mass is an unalterable constant. Look at the wireframe topographical map of the quarry and temple area. This specific slope represents procedural asset generation, algorithmically placed to provide a physically plausible terrain for a massive background data transfer. These complex pulleys and hundreds of oxen functioned as a narrative UI, a visual interface rendered by the matrix to justify the repositioning of assets and prevent system logic errors. The construction history of Baalbek serves as a visual distraction from a massive background coordinate repositioning event. These developer logs reveal the specific mechanism used to bypass physics limits. The system temporarily zeroed out the mass parameters to 0,0 tonnen, allowing models to move without friction. Once snapped into its final grid location, the system permanently restored the monument's density. The stones of Baalbek stand as residual artifacts of an elegant system hack used to bypass the unalterable code governing the simulation. A system-level override of this scale at a single site suggests that other monumental anomalies likely share the same patch signatures. If the Baalbek build required the matrix to cheat its own physics, we must look for similar exploits across the entire ancient world dataset. This transition from stone to raw matrix code hints at a wider pattern of Viter for Vendita assets, reused 3D models deployed to populate the global map efficiently. These lost ancient mysteries appear more like copy-paste failure, logical errors in the algorithm left behind by the system's developers. We need to move beyond observing history as tourists and start interrogating our physical environment like code crackers. The weight limits and engine parameters of our reality hold the keys to our true origins. The only question left is where the next glitch is waiting to be found.